Namaste, welcome back to Sthathapragna channel and you are watching AWS Cloud Projects for Beginner to Expert, and this is going to be the last video in this series that includes the two projects that were added recently. This is going to be the last one, and this is going to be about chatbots with a large language model. Okay, so this is project number 95, right? But we still have a couple of new projects added as part of serverless developer, and I think one more as a security or networking. I don't remember. They will be 96, 97, but as a machine learning engineer, this will be the last one. If I have enough time, I will also record those two. And I think that will be about it for some time. There won't be any videos on this one. We almost hit 100 projects. I hope you enjoyed this series. So let's go ahead and finish our last project in this particular series as a machine learning developer, which is about chatbots. You have you might have seen several chatbots all over the website on different websites, but let's see what their use case is. Hello, thank you for stopping by. I would like to create a chatbot that can help interact with our customers, and I hear that you are an expert. Yep, we almost reached at the expert level. Well, I've been experimenting with chatbots, especially how they can be integrated with LLMs, large language models. LLMs? What are those? LLM is the abbreviation for large language model. LLMs are very large, deep learning models that are pre-trained on vast amounts of data. Okay, great, but I'm not sure what LLMs have to do with the chatbot that I want. Can you explain? LLMs are incredibly flexible. One model can perform completely different tasks from another, such as answering questions, summarizing documents, translating languages, and completing sentences, something like ChatGPT. I'm starting to see how we could benefit from an LLM. Tell me more about how we can incorporate an LLM with our chatbot. AWS has a managed service called Amazon Lex, which is great for building conversational interfaces by using voice and text. Lex is powered by the same conversational engine as Amazon Alexa, and it provides speech recognition and language understanding capabilities, which you can use to add natural language chatbots to new and existing applications. Wow, sounds like this could really improve how we handle customer interactions. Tell me more about your customers. Most customers have general questions about our products. Many times the questions are part of long paragraphs that we need to summarize into simple one-line sentences. Awesome. We can experiment with a couple of pre-trained LLMs, and we can use SageMaker Jumpstart to quickly deploy the LLMs to a SageMaker inference endpoint. I will explain more as we build the proof of concept. That sounds amazing. Let's do it. Will you help us create a proof of concept that shows how Amazon Lex can be integrated with pre-trained LLM? Of course, I will. So along with SageMaker, I think we are going to learn how to use Amazon Lex. So let's go and hit it. Okay, here we are, and the video concepts will, of course, will have Lex overview. So watch all the videos if you haven't, and you can watch them in the playlist that will pop here. Click on it, go search with this title in the playlist, watch them, then come back and watch the rest of the project. This solution integrates Lex with LLM to help developers create advanced chatbots that can improve customer service interactions. You can create Lex version 2 bot to interact with your users to elicit information to accomplish a task. For example, you can create a bot that gathers the information needed to order food from a restaurant. Each task that a bot can fulfill is known as an intent. A bot must have at least one intent. By default, all bots contain a single built-in intent known as the fallback intent, and it is triggered when the bot does not recognize a user's intention. Developers and data scientists use SageMaker to build, train, and deploy machine learning models for any use case with fully managed infrastructure tools and workflows. We have used this in last 15 projects in this playlist, so we are already familiar with that. SageMaker Jumpstart provides pre-trained open source models for a wide range of problem types to help users get started with machine learning. Users can incrementally train and tune these models before deployment. The FLAN T5XL model used in this solution was pre-trained with several open source datasets. The model supports multiple languages. You can enhance the Lex bot by using its fallback intent mechanism to trigger an Lambda function. Lambda users can run code without provisioning servers and managing runtimes. We already know that. Lambda function uses the request from Lex bot to prepare the payload to invoke a SageMaker inference endpoint. Developers configure and deploy the model's infrastructure to the inference endpoint by using steps in the SageMaker Gemstart Jupyter notebook. The call to the LLM includes a prompt which sets the tone for the interaction. The call also includes a chat history to encourage a desired response relevant to the topic. Prompt engineering is crucial for directing model behavior and achieving desired responses. Using prompt engineering, developers can control a model's tone, style, and domain expertise without time-consuming tasks such as fine-tuning. So that's about it. So let's go ahead and see what the practice lab goals look like. We are going to use SageMaker Jumpstart to access pre-trained models such as FLAN T5XL for quick machine learning initiation and NLP tasks. Then we'll deploy ML models by using SageMaker real-time inference endpoint, and then we'll integrate Lambda with Lex using LangChain to connect with SageMaker. Implement an Lex V to fallback intent to handle unmatched user inputs. And as part of DIY, we are going to deploy a new SageMaker inference endpoint by using Hugging Face text-to-text T5 one-line summary LLM. Then we will upload the results file created after deploying the new model to S3 bucket. Then we will update the Lambda function environment variable with the new inference endpoint. So let's jump into this lab and let's implement these solutions. Let's start the lab. Okay, let's go through the tasks, and we are immediately going to SageMaker, and by the time we have the lab started, we will have the studio ready to trigger, and then we will as usual go into Studio Classic, and then we'll open the Studio Classic or Jupyter Lab, whatever you want to call it, and this time we are going to go into solutions, or not solutions, we'll go into the Jumpstart. In the Jumpstart we have models, notebook, solutions, and instead of resources we will go into solutions. And Jumpstart helps you quickly get started with ML. The solutions are fully customizable and support one-click deployment and fine-tuning of more than 150 popular open source models such as natural language processing, object detection, and image classification models. So we are going to click solutions, then we will use FLAN T5XL. Then we will choose new terminal, and we are going to execute couple of commands. And what do these commands do? We are listing the bucket, then we are trying to find buckets that will start with lab code, and then we are getting the $3, whatever the result of grep, third item we are picking it using awk. So at the end, I guess we'll get the bucket, I guess. Then we are using that bucket name and we are syncing everything in bucket to this particular folder. Basically, that's what we are doing. Instead of this, we can go to S3, copy the, grab the bucket, and then command sync it. We can do that, but well, let's try to do this, because I think these projects are made by different people, and each person, did this in their own way. Hence, we are seeing variety ways of implementing the same thing multiple times. All right, let's go ahead. Let me paste that one here. I don't know. I think it's because of the language. Let me just say, can I not just say text? Normal text. Yeah, here we go. Okay. Okay, that's what we are doing here. Then let's click next. And we are going to open the notebook called Chatbot LLM. And we are going to spin T3 medium. I guess that should be fine. And then we will follow the steps in the notebook that are listed. Let's click next. Next, and once that is done, we can go to the SageMaker endpoints and see the endpoint is getting created. We already checked this out, so we don't have to. And we can copy, what are we copying? We are copying the endpoint name because we have to update it in the Lambda. So let's click on the models. Okay, inference, we have models as well. Click next. And you can review the model URI, I guess. Tag, that is the tag. Then let's go to the next cell. Let's we will just go through this in the cell. Don't worry about it. Review. We'll go through there. And then let's go to the endpoint invoke function. Go to environment variables, edit it, update it, save it. Then let's go to the S3, the bucket called chatbot LLM. There is already Lex code, looks like. Download it. You can download a single object. Yeah, we already know that. Now let's go into Lex and import it from Lex. And let's name it chatbot LLM. Then browse input file. And that JSON, whatever zip file we downloaded, put it there. Use an existing role. They already created a role. Children's Online Privacy Protection Act. No, we don't have anything like that. It is available. Testbot alias. Click on it. That's what we created, I guess, alias name. And languages, click English. Source is going to be the endpoint invoke function. Okay, so that function. And then we are using the latest version of the function. And intents is going to be, we click on intent, then click on build, and then test. Okay, this is how it is learned. What is AWS? Okay, it's an international public cloud domain, XYZ. I think pretty much that's it, but our lab is not yet started. So let's wait for that to start. So basically, we are going to learn how to integrate Lex and trigger SageMaker models using the chatbot. So I think after looking at this, you might get your own ideas. Share it in the comments if you have any use cases for using a chatbot. Okay, the lab is ready. Let me open it. All right, let's go to SageMaker. Okay, and this should already be ready for us here. Let's open the studio. Okay, let's click on the Studio Classic, which is already ready. Let's open it. All right, we are here. Now let's go and click SageMaker Jumpstart. I mean, we are not going to do much here. We are just going to check the solutions that are available here. Let's search with, what is it? Flan T5 XL, right? I think this is the model. We are not deploying from here and training from here. Don't worry about it. So what we are going to do is we will import it from here into our notebook. So let's go file, new, terminal, and let's copy all the files from the S3. So let's first figure out what the bucket name is. Instead of going to the console getting it, let's write the commands. Then we got the bucket. So let's go ahead and sync it, not copy. Copy copies objects, not folders. So sync does everything. So S3 colon slash slash. Do we use dollar bucket? Does that work? To here. And it does work. So it brought a shell script and as well as the notebook. If I click here, you will see it here. Where is this here? So let's click on it. Let's not delay any further. Open it. And I think medium is fine. Select it. So welcome to SageMaker Jumpstart. You can use Jumpstart to solve any machine learning task through one click in SageMaker Studio or through SageMaker Python SDK. In this demo notebook, we demonstrate how to use the SageMaker Python SDK for deploying foundational models as an endpoint and use them for various NLP tasks, natural language processing tasks. The foundation models perform text-to-text generation. It takes a prompt text as an input and returns the text generated by the model according to the prompt. Here we show how to use the state-of-the-art pre-trained FLAN T5 models and FLAN UL2 for text-to-text generation in the following tasks. You can directly use FLAN T5 model for many NLP tasks without fine-tuning the model. So before executing the notebook, there are some initial steps required for setup, which is like install or upgrading the pip and upgrading SageMaker. So let's go hit it. To host SageMaker, we need to set up and authenticate the use of services. Here we use the execution role associated with the current notebook as the account role with SageMaker access, which is something that we were doing so far. So we will start the session, we will get the region and store the session in that variable, and then we will get the role as well. You can continue with the default model or you can choose a different model from the drop-down generated upon running the next cell. A complete list of SageMaker pre-trained models can also be accessed at this link, which we have seen multiple times. So here we are trying to get Hugging Face text-to-text FLAN T5XL version 1 point everything. So let's run this. Okay, so that's done. Using SageMaker, we can perform inference on the pre-trained model even without fine-tuning it first on a new dataset. We start by retrieving the deploy image URI, deploy source URI, model URI for the pre-trained model. To host the pre-trained model, we create an instance of SageMaker model and deploy it, which is something that we did in, I think, one previous project, right? Wherein we initially used what was the text to image, right? So we initially used the pre-trained model and we did the exact same steps. Okay, SageMaker client. Then we are local download setting it, and then the session. We are returning the session, nothing much. And next we are going to create a directory called that. We need to create a directory to host the downloaded model. This text-to-text generation task supports a wide variety of model sizes that have different compute requirements. Here we specify the instance type for several large models along with an environment variable to set the multi-model endpoint number of workers to 1. This ensures we can support the largest possible token length since additional models are not consuming GPU memory resources. Okay, so large model environment, server that, and model config map, large model. Okay, we are setting all these different instances, but we are not going to use all of them. And here we are actually, inference instance type when we deploy it. And then we have seen this in the previous one, image URIs. We are getting the image URI, then the model URI, script URI, and once it all is we get all of them, then we are going to build the model, then we will deploy the model. So this will take some time, so let me run it. It will be running in the background. Input to the endpoint, once that is done, we are not training it. Listen to me. Okay, we are using the pre-trained model. So the disadvantage with pre-trained model is when you run any test, it is obviously going to give results based on whatever the data sets that were used for the pre-training. So if you ask anything other than that, it won't have any idea. For example, if you trained it with all AWS documentation and if you go and ask about Azure, obviously it won't answer us because it was not trained on that. It was trained on just AWS data. Okay, so keep that in mind of the pre-trained. That's why we in the previous project, what did we do? We trained it. We trained it again using the company's data set. Okay, so here what are we doing? Input the endpoint in any string of text formatted as JSON and encoded in UTF-8. Output of the endpoint is JSON. Okay, that's fine. That's what we are giving. We are giving, these are just functions. We will give the input here. So text one, translate to German. My name is Arthur. Recipe, how to make Bolognese pasta. Then summarize whatever that is. Okay, so then we are opening a file and for text in all these three strings, we are sending it to the response and then we are printing all those lines out. So basically that's about it. So once this is done, I will come back and I will run these two. but you get the idea. This is similar to whatever we have done so far, but the difference is we are going to integrate this with Lex, right? Because this we are running it, but that's not how we will be doing. What we will be doing is once the Lex chatbot is deployed, when we ask a question there, for example, if I put the same question that I'm asking here in the chatbot, Lex will trigger a Lambda function, and that Lambda function will query it from the SageMaker, and the response will go back to Lambda. Lambda will give it back to Lex. So that we are going to do it in this project. So hold on until this gets deployed. Okay, here we are. This is done. So let's go ahead and create these two functions and run our text. So we should see that printout here. So translating German, my name is Arthur. It's that. I don't want to butcher it. How to make a bolognese pasta, bring a large, add the pasta and cook according to, I think that's it. Maybe we are trimming it. And then inference, as you can see, we wanted to summarize this. So that's what here it is. Okay. So good. Everything here is working as expected. So now let's go to here. Why here? Because we want the endpoint inference endpoints. I was like, seriously? There is no endpoint. That's it. And if you want to look at the models, you can look at them here. Okay. Yeah, you can see what all are running, how much the cost is prospective instances to deploy model. Okay, so once we have it, we are going to go to Lambda. Let's open that. And we are looking at endpoint invoke function. Let's edit this, replace it with this, save it. And this is not yet integrated with the Lex. So for that, we are going to go to S3. Oh, by the way, let's go back. Let's look at the code quickly. This will be similar to pretty much everything we are doing so far. Okay, so there is a function dispatch Lex version 2, Lex version 2 dispatcher, that request, and then we'll return dispatch intent because we need to send it back, right? Not just getting it. So when we are triggering the Lambda handler, we are getting the event. The event is from where? The Lex. It will give us that question or whatever the prompt you are asking. Then if session state in event, if intent in event, session state, if name in event intent, if that is fallback intent, then it is going to print dispatch lex2, else dispatch qnabot return true. Okay, hold on a minute. Where is it actually triggering? What did I open? What is the other function? Load data function. No, it has to be this, right? I'm just seeing where are we triggering the load balance. Sorry, SageMaker. Definitely not in this. We have the endpoint name, but what are we doing with it? Mm, it is this one. So let's open the other function. What is this about? Content of the buckets. Delete, response body, all that. CloudWatch. Okay, this has nothing to do with that. Okay, let me go here. There are some pre-created code here. Let's go ahead and explore that. This is the main one. Utils dispatchers. What does this dispatcher do? Dispatch intent. I think SageMaker endpoint. Okay, this is where it is happening. Okay, so if I go to this code, where is the dispatcher? Is this the dispatcher? Yeah. Okay, this is where we are executing it. That is actually contains all the code where it is triggering the SageMaker and getting and whatnot. Oh, okay, cool. So now since we already added that there, so let's go to Lex. And in the meantime, let me also go to, okay, not here, maybe here, S3. Okay, because we don't have any bots created, we need to import. Or how did they do it? Did they create a bot? I didn't see any of this, right? Did we? No. So let's go to Lex. No. Bots. Actions import. Let's do that. So let me go here. Chatbot LLM. Let's click download. Let's come here. Let me browse for the file. Okay. And once we do that, let's use an existing role and let's select that one. Bot name. Text to text. Lex is no. Let's leave them import. Okay, so it's in progress. Let's give it some time. Okay, it is done and it is available for us. And add languages. One language is added, which is English. Let's select it. I think that's what they told us, right? View intents. Describe Lexbot fallback intent. Use built-in intent, and we are going to select. Oh no, what happened? Okay, I don't think it is here where we need to add. Let me go see that. Okay, aliases. We need to go to aliases, not here. So let me go to bots. Click on that. Let's go to aliases. Let's click on that. Select the language. No, no. Is that it? Yeah. What is the source? Source is endpoint. I think that's the one, right? Let me confirm it. Yeah, endpoint invoke function. And the latest, save it. I think that's it. Intents build. Okay, so we need to build. I totally forgot about that. So we'll go to intents. Let's click build. Building language in bot text lex. If your language contains external source slot types, the build might take longer to complete. Yeah, we do have lambda, so let's see. And I think that's it, right? Yeah, then we will have, once it's built, we can click on test and we can ask whatever question we want. So let it build and let's go ahead and let's copy this from here. Let's see if it is going to result in the same text or not. Okay, that is done. Let's test it. And here is our bot. Okay. Yeah, I think it is going to take some time. I just asked this. Why are you giving me all that text? Wow. This is too chatty. What did we get here? Ich bin Arthur. And what is this saying? Wow. I don't even know if that is accurate. Okay, let's say I think AWS has more to do with cloud computing, especially in the US market. Conversation. Okay, did we not do something right? It is giving results, but not whatever they are asking. Okay, that's okay. I think pretty much that's about this one. So we implemented it. It is working. It is giving us, what is this? Oh, refresh everything. Now let's go to DIY and see what we have to do. Text to text T5. Upload the DIY results file created after deploying the new model to S3 bucket. Update the lambda function within, okay. Uh, okay, let's see. They want text to text if I hugging. Let me copy. Can I copy it? I don't think I can copy it. So let me go here. So let's click on hugging face. Text to text, they are not going to show us. Sorry, number two. I mean, they are not even text to text. T5. One line summary. Or maybe that's what I should search with. Okay, this is the one. Why am I here? If you are wondering, I want the name. Where can I get the name? I think even previously, I think I came to one of this place and couldn't get it. It's in maintenance. Wow. Okay. What if I say deploy? That's the end point. No. Okay, here we go. Oops. Okay, so we got the model name. So let's go here. Oh, they already have it here. I don't know why I struggled with that. I think this is the name, right? One line summary, that's what they want. So let's go here. And how are we getting, what is it? Model config IP. It's not that. It's not that. How are we? Yeah, I think this is the one, right? Model ID. Oh no, that is the environment. Okay. So how are we picking this particular one for this one? Let me see. If model ID in that instance type, what is model ID? Where did we get it from? I think we got it from somewhere, right? Where did we set it? Yeah, here we go. So we will use the pretty much everything same. Let's click on that one. Let's click on this. Is there anything before I trigger that? Upload the file created. Where is this file? It will be created, but if it is created, why are we uploading it? Okay, this one. Okay, what does it contain? This just contains the example text, generated text. What is this? To upload? That's weird. Okay, we'll see. Okay, let's go ahead and run this. Same thing, similar thing we did, but this time it is going to, instead of this one, it is going to use this one. That's the model. Resource limit exceeded. Okay, I think I know what is going on. So let's go and Okay, so let's go to here. Aren't we here? Deployments, endpoints. I think we are here, right? Let's click delete, confirm. Okay, they didn't tell us that, but I'm assuming since it's already running, it's not letting us do this one. So let's go and try to rerun this again. Okay, it's running. Let's wait for some time and I'll be back. Okay, this is done. Let's go ahead and create again these functions and we can run this if you want, but what did they say? Let's upload this, right? Let's upload this function. Okay, let's see. How do I run this? Can I run this from here? Can I run it? Clearly not. So let me copy all this, or I can run this script, right? Yeah, sh diy upload. I think that is uploaded to that. Okay, before I forget this, because I've been forgetting this all the time, let's go ahead here. Let's copy this name and let's paste it here. Validate. And as usual, let's see if we are going to fail the first time or if we are going to pass the first time and fail it. Oh, I thought of updating. I just said, right? I said I have to update it, and instead of updating, I came and pasted it there. I think the curse is still there, guys. The curse is still there. I copied it to update and I came and pasted it here instead of updating there. If that has to happen, that will happen, right? And now that's passed. Let me close this, and come back here and let me execute this. It should pass. I mean, we just used a different one, but it should still pass. And since our Lex is pointing to that, let me try asking the same question. Will it will it know what I asked? Will it correct it? I think it went to the default intent because it didn't understand the question. What? What I saw? It's not saw, it's AWS. I think it's gone. It's a goner. Seriously? Okay, let me see. What answers did it give? Did it give the right answers? Yeah, it didn't. My name is Ardhar. Translate to German. No, it didn't do anything. It oh no, I think we did we run this? I don't remember. Yeah, maybe we did. Let me ask this. Yeah, this is broke. So don't build anything like this. But anyways, it is done. That's what matters. We broke it with using that one line summary. Okay, what is happening here? We broke the AI, guys. That's how it should be. Imagine you go to a company and do something and then their model is gone, which they prepared, trained for years. Okay, yeah, I think this is fine, right? That would be awesome. Obviously, they won't. They will have copies of the model, but still, what did we do? We did nothing. All we did is changed the model to a one-line summary, text-to-text generation, and then we ran it. We didn't run the previous one as well, right? But you have seen the difference, right? Okay, anyway, since it's 100%, I'm going to get my batch. So with this, I technically got all the batches, all the 7 batches from these guys. So let's give that, click next. 25 solutions delivered. You completed us. Thank you. So let me go ahead and grab my batch. We'll be back in a minute. All right, I grabbed it. Let's close it. Okay, so let's finish the final quiz for the machine learning. And I think they will ask about Lex. And I didn't watch the Lex video yet. So you will score more marks, I guess. What are two ways that developers can get started experimenting and developing large language models? Jumpstart, you can go ahead and get that. I think it's Bedrock. I don't think it is these two. Yep, 1 out of 1. Hold on, where are you going? Let's go grab it. What is the meaning of LLM acronym? Seriously? Large language model. 2 out of 2. After a large language model is trained, it must be fine-tuned. Mm, Not really. I mean, you can fine-tune it, but does it have to? 3 out of 3. How are you guys doing? Are you scoring? Looks like there is one right on top of my head. Where was it? Is this the buggy area? No. Okay, we are good. It is the buggy area. Which AWS service can act as a fallback when a user's input to an intent isn't what a chatbot expects? Lambda. Lambda. Which use cases are built for a large language model? Text generation, text classification, copywriting, I guess. Look at that. 5 out of 5. Let's try to do the one of the orange one because this is going to be the end of this particular. Oh, seriously? Don't tell me you will also sink into that. Okay, this is the buggiest area, I guess. Okay, I think we can end it here. So thank you very much for hanging out throughout this playlist. If you watched all the 100 projects, I think you are in a better shape now. I think I think you can see the difference before watching these projects and after watching these projects, right? Don't you agree with me? Because these are what? Almost 100 projects. You should have gathered lots and lots of knowledge. And as I guaranteed, do you feel like you have that 3 to 4 years experience as a developer? Do you feel it or you don't? Let me know in the comments. Anyways, thank you very much for hanging out for all these videos. I really appreciate you all doing that. Have a great day and all the best with whatever you are doing. And see you in maybe some other playlist. All the best. Peace out.